Hey, what's up, guys? Welcome to day 4. We are going to be looking at the volume and surface area of rectangular prisms today. And we're also going to be kind of taking it a step further, and we're going to see what will happen if we end up changing one of the dimensions, okay? And so we're going to jump right in. So we're going to start by, I'm just going to give you the formula for the volume of a rectangular prism. All right, and so this one, again, remember you're going to be given a formula sheet, and it will be sort of on the testing site. So you don't need to memorize this, but you do need to know, okay, whenever I need a formula, I need to go look for it on my formula sheet. And so the formula for a rectangular prism the volume formula is length times width times height, okay? And so I'm gonna start by finding the volume of this rectangular prism. So I wanna always start by writing the formula, length times width times height, okay? And now I'm gonna identify what each of my dimensions are, okay? So my length, and this is an L, I just like to write my L's in cursive so that it doesn't, you're not mistaking it as a 1, okay? So my length is 11, okay? My width is 5, and then my height is 6, okay? And so now I'm going to multiply the 11, the length times the width times the height, okay? And that will give me my volume. So you can go over to Desmos and enter this in on your calculator, and what you will get is that the volume is 330 centimeters cubed, okay? So that is the volume. Simple enough, right? Length times width times height. Now what we're doing here is we are going to, it says the scale factor, we are increasing it by 2. In other words, what we're going to be doing is we are going to be multiplying the length, only the length. So we're going to multiply the length here by 2. And what we're going to do is we're going to see what the new volume is and see what the relationship is to that, okay? So now, okay, again, I'm going to start by writing my formula again. Volume is length times width times height, okay? Now my new length, after I am doubling my length by 2, by a scale factor of 2. So whenever I am, it gives me the scale factor, I am going to just take that number, I'm going to multiply it by the length, okay? And so once I double my length, it is now going to be 22, okay? And my width is going to stay the same. That's 5, and that the height is 6. Again, it only said that I needed to increase the length by a scale factor of 2, okay? And so then I'm just gonna plug these in. So I have 22, length times width times height, okay? I'm multiplying those 3, and when I do that, I am going to get my volume equals 660 centimeters cubed, okay? And so when I do that, all right, I want to see what is the relationship between that one. So once I increased it by 2, well, originally it was 330, and now it has increased to 660 when I multiply the length by 2. And so hopefully you see that these numbers also increased by 2. When I increased the length by 2, the volume increased, it doubled by 2, okay? So the change here was that when I increased the length by a scale factor of 2, the volume doubled. Okay, it also increased by 2. All right, so that's, again, we see that. All right. And so now I want to see what will happen if I, this time I'm going to increase the scale factor by 3. And so I'm going to triple it. And I want to see if the relationship is that it will also increase by 3. So let's do that again. So start with our formula, the volume of a rectangular prism is length times width times height. Okay. Now this time my length is going to be, again, I am tripling, not this one, I'm tripling my original. Okay, so my original length was 11. Now it is going to be 33. Okay, and my width is still going to be 5, and my height is still going to be 6. Okay, and so then I'm going to multiply each of these. Okay, so 33 times 5 times 6. Again, I can enter this into decimals, and when I do that, I'm going to get that my volume is 990 centimeters cubed. Okay, and so what we see is once I increase the length, okay, it was 11, I increased it to 33, that also made my volume triple. Okay, it made it also increase by a scale factor of 3. So again, the same thing happens. So we see that whatever we do to the dimensions in a rectangular prism, when we're finding the volume, it will also affect our volume that way. So if we double it, then the volume's going to double. If we triple it, the volume's going to triple. If we take half of it, the volume will be cut in half. All right. So what I want you to do is I want you to pause it, and you are going to show, do the next 2 examples. Okay, so we've already discovered what the relationship is, and so you are going to verify, does it work when I do the width? Does it work when I change the height? Okay, does it work when I take it half, or when I multiply by 4 the height? So again, now what we're doing is we are doing what we just did, but this time we're changing different attributes. We're changing other dimensions. So make sure you pay close attention to which scale factor, which dimension you're increasing, and then just take a look at what happens, right, when those things change. All right, so do that. Again, the middle one is when you're changing a width by 2, and then when you change the height by 2, you're going to see what that relationship is. Then the same for length and height. All right, so again, I want you to describe the relationship, and once you're done, raise your hand. I'd love to come look at what you find, and then we're gonna, for the rest of this video, I'm gonna move on to surface area. Okay, so finish that, and then let's continue with surface area. Okay, so surface area. To find the surface area of a rectangular prism, you need to write this formula down. Actually, let's go. Rectangular prism. Okay. And this defines the surface area. Okay, the formula that you're going to need here is SA equals, again, this can be found on your formula sheet. It is 2LW, that's 2 times the length and the width, 2 length and the height, and then 2 times the width and the height. Okay, so I'm just going to do the same thing, but this time I'm going to use the surface area, and we're going to take a look at it. Okay, see how it affects. So I'm going to start by writing my formula. Again, you don't have as much space here because this formula is a little bit longer than the volume formula, okay? And so I want to start by writing down my dimensions. So my length is 11, my width is 5, my height is 6, and now I'm just plugging them into the formula, right? So 2 times 11 times 5 plus 2 times 11 times 6, which is the height, plus 2 times the width and the height, 5 and 6. Okay, so I'm just multiplying again and adding those. You can put that in Desmos exactly out as it's written. And when you do that, you're gonna get that the surface area is 302 centimeters squared, okay? And so now we're taking the width, just the width, okay? And we are going to increase it by a scale factor of 4. So I am going to multiply, okay, the width right here by 4. Okay, I'm multiplying the width by 4. So let me go ahead and write my formula down again. Okay, and then my length is still going to be 11. My width, this is the time, this is what's going to be increasing. I am multiplying it by 4, okay? And then, I'm sorry, multiplying it by 4, that will give me 20. And then my height is still going to remain 6, okay? And so now just plug that in. So 2 times 11 times 20 plus 2 times 11 times 6 plus 2 times W and H, 20 times 6, okay? And so then I just plug that into Desmos, and it is going to give me that my surface area is 812 centimeters. All right. Do the same thing one more time. This time the length is increasing by 3. So I am multiplying this by the length. Okay, length by 3. All right, I'll write in a different color this time. All right, so again, write in my formula, 2LW plus 2LH plus 2 width and the height. All right, so the length is 11. Oh, no, sorry. The length is, again, being increased by 3. Okay, so I'm multiplying the length by 3. Okay, multiplying the length by 3. Then I am multiplying, so that should be 33. And then the height and the width and the height are going to stay the same. So it's 5 and then 6 for my height. Okay, and so now I want to see. All right, just going to plug those in. 33 times 5 plus 2, 33 and 6, and then 2 and 5, 6. Okay, and so multiply that, put it into Desmos. It's going to end up giving me that the surface area equals 1,956 centimeters squared. Okay, and so now again we had the scale factor increase. So now I want to look at it and see what is there a relationship like when we increase the volume. Okay, so first we're going to look at this first one. Okay, when I increase the width by a scale factor of 4, what we would expect if we were thinking about how it changed with the volume, we would expect this to also increase by 4. But it didn't do that. It did increase if I, let's imagine this was 300. If I do 300 times 4, that would give me, 1,200. So it did not increase in the same way that when we increased the volume, all right? The same thing with when we multiply the length by 3, right? If I multiply the length by 3, we would have expected this number to also increase by 3, okay? And it did increase, but 300 times 3 would have given me 900. Okay, but we see that it actually increased by a lot more. Okay, so when we multiplied it, it did increase, but not like it did when in the volume. But it did not increase proportionately in the same way that it did with volume, but not. Okay, it did not increase it with the same the same factor. Okay. All right, so that is, I've shown you in this video how to, take the volume and the surface area and looking at how you change different attributes, how that affects the volume and the surface area. What we've seen is with the volume, it does increase by, if you increase one of the dimensions, it changes the volume by that same amount. But with surface area, the same doesn't happen, all right? And so I want you to continue to investigate. You just got one to do for surface area because those are a little longer. So continue to investigate. See that does that work in all cases? And let me know. Like it, comment, and thank you for watching. Good luck as you continue to practice finding the volume and surface area of rectangular prisms.